Hello, my name is Thomas Abraham, and this is my MSc dissertation presentation video for my project titled Predicting the Final Seeds of National Basketball Association Teams, a Machine Learning Approach. The aim of the project was to accurately predict each of the 15 seeds for both conferences in the NBA at the end of a regular season. The ability to accurately predict the final seed of an NBA team is of great benefit to team staff and bettors as they enable the public as well as the staff to determine potential round one matchups in the playoffs. The algorithms and models being considered here are the ELO algorithm, random forest classifier, and logistic regression. The main aim here is to run the ELO algorithm on a regular season and then compare its accuracy with the logistic regression and random forest classifier to help determine the best possible model to be used. Moving on to implementation methods, all three algorithms, the ELO algorithm, the random forest classifier, and the logistic regression model were all implemented using Python scripts. And all datasets required were either scraped from stats.nba.com or exported from Basketball Reference for the required season. The main libraries being used were NumPy to work with multidimensional arrays and, of course, linear algebra, Pandas for data analysis, scikit-learn to use random forest and logistic regression, matplotlib and seaborn for plotting and data visualization, and lastly and most importantly the NBA API for data scraping. Moving on, we will begin execution with the ELO algorithm. First of all code is present on my GitHub repository, the link of which will be provided at the end of the video. There is a main README file, and if you are to go into each individual folder for the code, there is an additional README file provided where you can execute these commands and see the result for yourself based on, and the code can also be slightly edited for various other NBA seasons. Moving on. So we will begin with the train test file. The aim of the train test file here is to predict each individual matchup based on the team's plus or minus ratings, which were generated by combining each of the players' individual plus minus ratings, and predict outcomes for each of the 1,230 matches. It will then compare those predictions to the actual outcome of what happened in that season and generate a graph showing prediction accuracy. Each of the CSV files shown like this are scraped directly from stats.nba.com and are also available in the zip file and as well as GitHub. Now, as you can see here, the team on the left, for instance, Minnesota and GSW Golden State Warriors. The team on the left is the home team. The team on the right is the away team. The L indicates that the home team lost. So in this particular case, Golden State Warriors won. And as you can see at this particular point, the prediction rate is roughly 60, just below 60%. Now, as you can see, based on the ratings predicted for the entire season, a graph is generated using matplotlib. And from the graph, we can see that there is a roughly 63% prediction rate. I will now move to the execution of the ELO run file. What the ELO run file will do is generate all the ELO ratings for every single team in both conferences at the end of the regular season. And in addition to that, it will also provide a prediction for the playoffs based on the brackets, which will then be compared to the actual brackets and their outcomes. The season we're running here is the 2018-19 season. If you wish to run it for an additional season, you can uncomment these lines and run them as well. Each of these three letters corresponds to a particular NBA team, and the bracket prediction which occurs here will be compared to the actual bracket which has been manually inputted. So first, the code predicts a win per round of the playoffs and changes the rating accordingly. Now, if you'll go to the bottom, you'll be able to see the playoff rate. These are the ELO ratings for each particular team at the end of the regular season. This is also provided in tabular format in the report. Moving on, these are the teams that are expected to qualify for the Eastern and Western conferences. The reason this is important is this corresponds directly to the result, which is each of these teams are in order belong to the seeds of their conferences. For instance, first seed in the Eastern, second seed in the Eastern, first seed in the Western, second seed in the Western. That concludes the ELO execution part. Moving on to the execution of the random forest classifier. Each individual block of code can be executed, and the CSV files present here are also available in the dataset folders, and they were obtained from basketballreference.com and pertain to the 18-19, 19 and 20 and 2021 NBA season. Each of these commands is executed sequentially, and ultimately the aim is to obtain a report such as this using the classification report from scikit-learn. Moving on to the logistic regression model. Files consist of main two files, NBA predict and make pass predictions. So what NBA predict does is it generates predictions for a particular date and gives you the expected outcome for all matches on that particular date. For in order to run this particular function call has to be edited. So these three dates correspond to the date for which the NBA games are taking place, the season that they are taking place in, and the start date of the season, which has all been mentioned in the comments. These can be edited to produce the results for any given date for any past season. Only a result like this is obtained where there is a percentage chance given that a particular team will beat another. Moving on, I will now show you the execution of the make pass predictions file. So what happens here is this file will create a CSV prediction file of all past games that happened in a particular season. These can be between any two given dates for any given season or even multiple seasons. So right here you can see this is the function call which has to be edited in order to get the results for various other seasons. I have provided these in the comments and they can be uncommented if it needs to be checked. It is also important to note that the execution of this particular code will take several hours if the date range is very large. After execution, each of the teams is put in tabular format as per their various statistics and coefficients, and confusion matrix like this is generated and also plotted using Seaborn. This is the final accuracy, precision, and recall for the number of matches that I just ran. After the completion of the execution of all three models for the 2018-19 season, we can now move on to determine our key results and findings. We'll begin with the ELO algorithm, which constitutes the main component. Now, as you can see, the images depicted on the left and the right consist of the actual seeds for all 15 teams in both conferences at the end of the 2019 season, and the table in the middle depicts the predictions generated by the ELO algorithm. As you can see, they've all been ordered in ascending order of their ELO ratings, and analysis will infer that there is a roughly 63% prediction accuracy right here. After the execution of all three models, we find out that the ELO algorithm has an accuracy of 0.63, random forest 0.55, and logistic regression 0.67. This indicates that the logistic regression performed the best. These results directly relate to the features and metrics being used in their considerations. Additional features may result in more accurate results. As mentioned earlier, all available code and documentation is available at this link as a backup and can be used when required. Thank you for your time.